So today we're going to see how to balance a chemical equation. But the first question is, why do chemical reactions happen at all? To answer this, consider two simple scenarios. If you and your friend are sitting together in a room, you both are not going to keep quiet. You will start talking to each other and hence will interact with each other. Similarly, when different kinds of atoms and molecules are put together in a container, they start interacting with each other, which results in their rearrangement. And this rearrangement is what a chemical reaction is all about. Now, the number of ways in which this rearrangement can take place is infinite, and hence the number of chemical reactions that happen around us are also infinite. But the surprising thing is that all the chemical reactions are based on one single law, which is the law of conservation of mass. It states that equal quantity of matter exists both before and after the reaction. Only its rearrangement takes place. How does this actually happen? Let us consider by taking the example of a reaction between carbon and oxygen to give us carbon dioxide. To help you visualize this, here we have a carbon atom interacting with an oxygen molecule to give us a carbon dioxide molecule. If you notice, on both sides of the equation, we've got one carbon atom and we've got two oxygen atoms. Such a chemical equation in which the number of atoms of each element is same on both sides of the equation is called a balanced chemical equation. Let us see one more example. In the reaction between hydrogen interacting with an oxygen molecule, we get a water molecule as the product. But in this equation, if you see, we have got unequal number of oxygen atoms on both the sides. And such a chemical equation is called an unbalanced chemical equation. But such an equation is not very useful in chemistry because it only tells me that hydrogen reacts with oxygen to give me water. It does not tell me how much hydrogen reacts with how much oxygen to give me how much water. Also, if you notice, for making one water molecule, I need only one oxygen atom. Therefore, out of the given two oxygen atoms, I can make two water molecules. But now for making two water molecules, I also need two more hydrogen atoms, which I get in the form of one hydrogen molecule. So now, if you notice, we've got equal number of all the atoms on both sides of the equation, and hence we've got a balanced chemical equation. So now if you notice, we have got equal number of hydrogen and oxygen atoms on both sides of this equation. Since we have two water molecules and two hydrogen molecules, we put a 2 in front of them. Hence, now we have got a balanced chemical equation. Now you all might be wondering that since we have only one oxygen atom less on the right hand side, why not we simply add it there? Now if you notice, again we have got a balanced chemical equation. But now on the right hand side, we no longer have water. We have this molecule H2O2. Which is a completely new chemical species, and hence we have got a completely new chemical reaction altogether. Also, doing this would be equivalent to saying that, let's say, if I want to have 6 chicken legs for my lunch, I go out and start looking for a 6-legged chicken. Now you would think that I'm stupid because all I need to look out for are 3 normal 2-legged chickens. Therefore, if I want to have 6 oxygen atoms, I do not need to go out and start looking for an O6 molecule, but all I want are 3 normal O2 molecules. So from here you can see that always in a chemical equation, we change the coefficients and not the subscript. Hence, the correct way to balance this equation would be putting 2 as the coefficient before hydrogen and water. So this is the correct balanced equation that we have. Let us learn balancing by taking another example. Usually while balancing any chemical equation, we leave hydrogen and oxygen for the last. Also, if any diatomic molecule present in the equation is balanced at the end. Hence, in this equation, we start by balancing carbon, then hydrogen, and then finally oxygen because we have it in the diatomic molecule form. So if you compare, you will notice that on the LHS, we have one carbon atom, and on the RHS also, we have one carbon atom. Hence, carbon is balanced. For hydrogen, we have 4 on the LHS, however, only 2 atoms on the RHS. And again, to balance this, we will multiply this by 2, which we change by changing the coefficient and not the subscript. Now at the end, we notice that we have 2 oxygen atoms on the LHS, but we have 4 oxygen atoms on the RHS. Now again, to balance this, we will change the coefficient of the O2 molecule and change it to 2. So if you see, we've got equal number of atoms of each element on both sides of the chemical equation. Hence, we learned how to balance this equation. We now take the example of a reaction between lead nitrate and potassium iodide to give us lead iodide and potassium nitrate. We first learn the use of bracket and the subscript here. Whenever we have any polyatomic species inside a bracket and a subscript with it, then that subscript is associated with each species inside the bracket, which means that here I have got 2 atoms of nitrogen and I've got 3 into 2 is equals to 6 atoms of oxygen. Now in such a case, I can balance nitrogen and oxygen separately. But whenever I have the same polyatomic species on both sides of the equation, it is advisable to consider that species as one unit. Hence, here I will take nitrate as one unit and balance it separately. And after which I balance lead, potassium and iodide. So now if you see, on the left hand side I have 2 NO3, whereas on the right hand side I have only 1. And to balance this, I change the coefficient here. If you take the case of lead, we have got 1 lead atom on each side of the equation, hence it is balanced. For potassium, I have 1 on the LHS and 2 on the RHS. So I balance this by changing the coefficient of lead iodide. Lastly, I have got 2 iodide atoms on left hand side, similarly 2 on the right hand side. Hence, we now learned how to balance a chemical equation.